Welcome to BCS online lectures. This is the second lecture in software development subject. In this lecture we will discuss about software development models. We are still in the chapter 1, which is fundamental concept of software development and programming process. So in this lecture we will discuss about software development models. First, we will discuss about software development process, or we call software development life cycle, or SDLC in short. Then we will discuss about the waterfall model. We will discuss about different models of software development. First thing is waterfall model. Second, evolutionary model. Under that, we will discuss about a prototyping model. Then we will discuss about rapid application development models, or we also call agile methods. Under that we will discuss about incremental and iterative development process and dynamic system development models. So the software development process, which is also known as software development life cycle, in short we call SDLC, is a set of activities involved in creation of a software product. There are many different models, or we call methodologies or methods, used by software development industry. Right? The selection of a particular development method is depend on various factors. These following factors we'll discuss. First, characteristics of the software project. Then characteristics of the development team. Characteristics of the client. Risk associated with the project, and time and availability of the resources. So our goal is to develop a software product for a client or a user. So to develop this software, we can use different approaches or different methods. The selection of this kind of method is depend on these factors. First, characteristic of the software itself, software project or software itself, right? The software, for example, we will consider we want to develop a software for a shipping company. So the requirement of the software is to develop, to handle the process of a shipping or a logistic company. So according to this requirement, we need to select our method. So this method is different from if we want to develop a software for a word processing, for example, or spreadsheet process, right? If you want to develop a software for gaming, for we say you want to develop a gaming software, and there's another project to develop a software for a logistic company. So the nature of the software, right, is different. Because of that, we need to select different model for these projects, right? That's what we call the characteristics of the software. We can choose different models. Then the characteristic of development team. So if we have a development team which is expert in object-oriented programming, we will discuss about object-oriented programming. So the method we need to use should be suitable with object-oriented programming. Right? If you have expertise in like structured programming, we need to use a method which is suitable with that programming method. Right? If you have a Java developers, then we need to select something suitable for that Java development process. So according to the development team and the expertise of the team, and available the programming language expertise, or the designing of the interfaces, like that, according to the development teams, we need to use a suitable method. Then the characteristic of the client. Now we say the client want to develop a software for his retail outlet, let's say a clothing retail outlet. The client is saying, I want to develop a full software for my business, but first I want to handle the sales process only. I want to handle the billing process, right? First give me a software which I can do the billing. Then you give me the second part just to handle the stocks. Then you give me the another part to handle the creditors, right? Right? Like that, the client is asking software to deliver in part by part. So that then we need to use a software development method which is suitable for that kind of delivery. So we need to develop the software structure which is suitable with that of modular development. So the characteristic of the client, we need to select the suitable development method. Then the risk associated with the project. If the project is associated with high risk, we need to use a more precise development method. For example, if you want to develop a software for medical industry which require high precision, right? So we need to use more mathematical, more engineering method to develop that kind of software, because single error is depend on another human life, right? This software is associated with the life of a patient. Therefore, it should be high precise. So we need to use a software development method which is more engineering, which is more scientific and mathematical, right? So the next factor is time and availability of resources. If the client asking to develop and deliver the system within a short period of time, we need to use a development methodology suitable with to develop in a short time, right? Also, if we have limited resources, so then we need to use that kind of method which we can use the maximum use of our resources and also deliver the project in short period of time, right? How to minimize the cost of development, still delivering the project in a profitable margin. So that these kind of factors we need to select the suitable development method. So let's see what kind of method available in developing of software product. Right? First model is waterfall model. This is the first model used in software development engineering. It is a linear sequential flow of different phases. This model relies on the completion of the previous phase for the following to begin. Because the model does not support going back to previous completed phase, right? The waterfall model should be used for projects with clear definitions and outcomes, right? Now let's see this diagram. Waterfall model is a linear process, right? Linear sequential flow of different phases. Now it's going like a waterfall, step by step, from top to down, right? Because this is the more engineering approach, okay? Considering to with the next other development the models, this is more engineering process, because these phases requires clear definitions of the requirement, right? Now if we consider this waterfall model, the first it has 1 2 3 4 5 stages. Some diagram outline 7 stages, 6 stages, or even 8 stages, but basically there are 5 stages, okay? First stage is requirement definitions, right? Requirement analysis and definitions. In this stage, first we need to identify the requirement or the objective of the software, right? Objectives, user requirements, right? And then business process, right? Every aspect of the business we need to first document, right? This is a highly skilled analysis process. There are separate people called system analysis, right? System analysis for do this kind of process, because analyzing the business from every analysis, user behavior, right, business flow or the activity flow, right, then the output, what kind of documents need to produce, what kind of reports need to produce, what are the input data, right? All these things need to first analyze and document, because all other phases, right, this is the first stage of waterfall model. All other 4 stages depend on this stage. If we made an error in this stage, that error will go to all other stages, right? So therefore we need to be very careful on this stage, because this is the very most critical phase of software, the phase of waterfall model, right? The next step is system and software design, right? Okay, first we do the analysis of the business, then we identify what are the input data, right? How the data is processed through the system, what are the output data, what kind of reports we need to generate, right? So like that, who are the users involved in software, right? The software system users, right? Then the access privileges, right? What user can access to the what phases of the software, all right? So how user involved in the different phases. So all these are first we have documented in the requirement definition. Now with that document, we produce a document, right? With that document, we need to design the software, right? It's not actually developing the software, right? But design. It's also a document, right? This is called requirement specification, right? That is the document generated in the previous page, that the requirement definition page, is called the requirement specification. Based on the requirement specification, we design the software, right? In this is also a document, right? In this document include the requirement of hardware, what kind of hardware we need to run this software, then the software architecture, that means what are the user interfaces, right? Then how this input data is processed through the system using flow charts. Then pseudocodes, we will discuss about the pseudocodes, flow charts in coming lecture, right? But what I want you to understand is this is not the actual programming phase, but all the data that we gathered from the previous stage, we visualize the system, right? Right, we show that using the diagram how this input data is going through the system and produce the final data. For example, let's consider, right, producing of a machinery, right? There's a company who produce we say hand drills, right? Hand drills, you also know the hand. Okay, forget that one. We'll take a more common example, right? Producing of clothes. Okay. So now first, company should get a design for the clothes, for a shirt, right? Then they get in the design, then purchasing materials, right? After purchasing materials, we need to go through the manufacturing process, and the final product should go through the quality checking and then packing and go to the retail outlet. So that's a simple example I got, so you can all understand that, right? So in this software design process, it shows, okay, we need to get the design. Okay, there's a designer, right? Designer send designs to the department of this design handling department. So okay, they decide what kind of materials we need to get for this shirt. Then it's sent to the purchasing department. Purchasing department purchase materials from suppliers. Right? So all this part, right? Getting the design. We involve designer, right? Then the design is safe. Design come to the system, right? Design save as a image file, right? Then based on that one, we give a style code, right? The style code is used for throughout the manufacturing process. Right? The style code, using the style code, we get different materials. According to material, then add style code plus material code. So because if that can involve different colors, right? The same shirt can have different design and colors. So then the style code, then after purchasing part, we get the style code plus color code, right? This is style, this is the color, right? It goes through the different manufacturing channels. So all these things we need to document and show, right? Using a chart. Right? Oh, this is how it going through the process. So that is what doing in the system design process, right? So after implementing, this is a huge process that involve in highly skilled people, right? Because there are system analysis and system architectures. System analysts do the analysis part. The system architecture do the designing part, right? So after the system design or the architect, okay, this goes to the actual development part. This is where the coding is happening in the third stage, which is implementation and unit testing, right? Based on the system design document, system implement or develop as a small functional units. These are called units, okay, or modules. These units are then tested using unit testing. We will discuss about this testing in the coming lecture, right? A document is produced explaining functions of each unit and relations to other units, right? Okay. Now this is what happened in this part. In the system previous stage, it clearly defined, okay, this is how to handle the getting of a shirt design to the system, okay. So that is the one part. So how to develop this develop this part, right? So developer gets a descriptive document of how to do this process in coding language. So for example, if you want to develop this code using Python, so that chart, right, or that document explain everything that the Python developer need to understand how to do this part, right? So what Python developer do is convert that document into actual system using Python language, right? So database will be created using by the database architect. So in that database could include who the style supplier is, right, or the client. Then it will have a style code assigned. Then other aspect, right, whether it is a shirt or a trouser, right, like that. The category, all those details will first include input using a user interface. So the user interface need to develop based on that document. Then user interface, after developing the user interface, we need to actually develop the program to handle those input data, then save those data into database, right? That is what actually programmer is doing. So this part is actually implementing that one and also testing. Right. We first the developer implement, and then we need to test whether it is actually functioning correctly, right? Like that, one unit is developing that one, and another unit is developing another part. Then we try to integrate those things, then testing, and if there are any errors come, we need to rearrange the programming and solve the problem. And it's a internal process of development and testing, and after finishing the modules, okay, they go to the next module and try to finish the whole system, right? Whole system, trying to finish the whole system. Then the full system is again testing. So this is a very intensive testing process involved in this this space, right? This is the most time-consuming part, right? More than those two stages, this takes more time to develop the system and test the system, and because we need to do the test unit by unit, then we need to integrate those units, then we need to test the whole system. If there are any errors, we need to go back to the units and adjust the errors, right? This is a whole set of complicated and time consuming process, right? After that phase, actually we have the system, we have the final product, right? That final product come to the next stage, which is integration and system testing, right? So the actual system now we installed on the client location or client computers, right? So this is now we discuss about this clothing factory, so we go and install the software in clothing factory, then ask them to use. Now the problem, then there are another problems can come, because once they are using, they are the actual users. There is also, this is also called a testing part, right? You install the system, parallelly we run in the system with their old manual process. They have a manual process that we don't interrupt the manual process. Manual process is also going, and we install the system parallelly to the existing process and ask them to run the system. If there are any errors, then we need to go back to the development team and ask them to do the correct errors, then come back and install the system again and ask them to run again. Like this is also integration and testing, right? This space is not actually using the system for in the production, but parallelly with their old system and this software system also going. This is called actually the parallel implementation, right? There are another type of implementation which is we install the system and completely forget the old system, and we try to go with the new software system. Then if there are any errors comes, we don't go through the manual system, but we only go through the this system. This called straightforward installation, or only the system installation. Other one is called parallel running. Okay, so this part we actually install the system and ask the user to test it. So now user is testing and user says okay, system is good enough to run. So we are going to now abandon or forget the manual process. We are going to stop the manual process. Now we will go only with the system, right? Then the next part is operation and maintenance, right? We call deployment, operation and maintenance. The final working system now deployed in the actual working environment. Now end users of the system will use the system and give feedback to the development company about errors and possible improvement of the system, right? Based on the feedback, the development process could go back to any of the above phases and incrementally develop the required changes, right? Now origin system is now our new system is now running on the factory, right? Time to time they could give, okay, now we need this kind of little small changes or the improvement, right? So that improvement go, whether it can go to the implementation and unit testing part, or it can go to the system design phase, or it can even go to the first stage, then come back like a waterfall, then from above to bottom, then that changes could come and go to the final operation and maintenance part. This is called the final stage, which actually run in the system, but still there could be changes involved in the software system. This is called the waterfall model, right? Now let's see the advantages and disadvantages of this waterfall model.